Hi there, it's Mrs. Nelson, and welcome to the second half of the electricity unit. So this unit, we're going to take what we know about static electricity and the idea that those electrons are the subatomic particle in the atom that are able to move, and we're going to apply it to household circuits and appliances and things like that in our current electricity section. So task 1 on page 6 in your book that I asked you to do yesterday asked you to kind of just draw or write anything that comes to mind when you hear the words current, electricity. So I just thought I'd take a minute and go through that. You'll have to excuse kind of my drawings here. But these are some examples that I've had in the past. So here's up here in the corner, I'll just maybe get a highlighter here and highlight them. Here's like your wall electrical socket. This poor person is putting their hand near it, so that's obviously not a good idea. So we will also be talking about a little bit of safety. We've got a light bulb here. Hopefully when it's attached to this battery, the light bulb lights up, a light switch in our house, and then other students have given hard drives, anything that kind of plugs in, video games, that sort of thing. They're a little harder for me to draw. So hopefully that helps, and hopefully you were able to come up with a couple of things for the top of task 1 on page 6. So we're going to start our notes. Again, we're on page 6, and we're going to be ending on page 8 today. So electrical energy is the flow or movement of electrons. So we've spent some time in chemistry talking about the parts of the atom, protons, neutrons, and electrons. In our static unit, hopefully you got the idea that electrons are the only particle in the atom that's able to move. So electrical energy is the presence and the flow of an electric charge, or of those electrons. So the energy portion of electricity is found in a variety of phenomena, such as static electricity, which we've talked about, electromagnetic fields, and lightning. So humans, we have found the ability to harness and store these phenomena. And we can harness it and store that charge for later use. So electrical energy is the result of the interaction of those subatomic particles with electromagnetic force. Within an atom, electrons and protons create charge. This charge can be transferred between bodies when using direct contact, that charging by conduction, with a conductive material. And we've already talked about what sort of things can be good conductors. So two types of current, and we're just going to briefly mention this. We're not going to spend a ton of time on this. We're going to mainly deal with direct current in this section. So current refers to the movement of charge, and again, specifically the movement of electrons, because that's the particle that's able to move. So direct current is often referred to as DC current. It occurs when the electricity is stored in a battery. Okay, and DC current occurs or travels in one direction. Sorry, I'm just undo. Where's my undo? Oh goodness, I'm hiding it here. All right, sorry about that. Let's move this here. I'm just going to try to move this. It's covering up some of the words. Oh goodness. Or it's just, I don't know where it's gone. I don't know why those words are covered up. Anyway, so direct current occurs when the electricity is stored in a battery and travels in one direction out of the battery. So if we look at this little diagram here that I'm going to pop up, here is our battery down at the bottom here. Okay, so there's the battery. We've got the positive end of the battery and the negative end. Ends are called terminals. In this case, electrons are stored at that negative end. That's what the negative means. It means it's got lots of electrons there. We've separated the protons and the electrons. So we've got all the electrons. And when we connect it to this circuit, the electrons flow out of that negative end. They flow through this light bulb, and hopefully that would light up the light bulb, and then back to that positive end. And we'll talk lots more about that over the next week to 10 days. Alternating current occurs when the current changes direction repeatedly within an electrical system. So the alternating current is usually used to power larger objects such as residences. So that's a fancy word for houses, buildings, that sort of thing. So you'd have the current would go in, oops, goodness, where's my highlighter here? In one direction for some way, and then it would reverse and it would go in the other direction. Okay. So when we have a circuit, and we're going to kind of pop back to those DC circuits, to light a small light bulb, we would need some sort of energy source, like a battery. So again, you're filling in that. You should probably also fill in the examples as well. Something to carry the electricity, like wires. Something to convert the energy into light. So we need something to convert that energy, so a light bulb. And a closed path. for the energy to flow. So as often we put a switch in our circuit so that we can easily break the circuit so that the light goes off. A cell is the most common type of battery used today. Each cell has a positive terminal, and again, that word terminal means end. I'll just get a pen here. And a negative terminal. A combination of cells that converts stored chemical energy into electrical energy is called a battery. So ends or terminals, both terminals must be contacted, so they must be touching to close a circuit. Both terminals must be part of the circuit so the electricity or electrons can flow or move from the negative to the positive terminal. The conducting wire allows for the easy flow of electrons through it. Resistors, the bulb converts the energy from those moving electrons to light and heat energy. So a resistor represents many different types of loads that convert the electricity to other forms of energy. So motion, heat, light, sound. So we could have a resistor that converts that energy into light, like a light bulb, or heat, like an electric heater, motion, like a fan, sound, like a radio. So any of those things. And it's important to remember that energy cannot be created or destroyed. It can only be converted. So this is called the law of conservation of charge. So we can't destroy those electrons. We can just transfer them from one object to the other. So moving charges. The circuit allows for the electrons to move from the negative end of the battery to the positive end of the battery, the negative terminal to the positive terminal. Electrons carry a negative charge, and they actually, when we kind of separate them and they're all bound up at that negative end of the battery, they're actually repelling each other. So once they're allowed to move through the wire, once there's actually a path or circuit for them to flow through, they're actually going to, part of the reason they'll actually move is because they're repelling away from each other in that wire and from that negative end. So that force of the electron repulsion helps to move the electrons along, and then it's also attracted to that positive end of the battery. A circuit can have a switch, just like a light switch, that can open and close the circuit. The switch interrupts the flow of electrons. Circuits can be described in circuit diagrams. So what I have for you is I've got a video in the folder as well, and you watch that video and you actually draw the circuits at the bottom of page 7 into the circuit symbols. Okay, so circuit symbols are often called schematics. They're similar to words, but they make communication quick and accurate. If you've taken electronics, I need you to use the science schematic or circuit symbols, not any other ones that you may have used in a different course, so make sure you're using these ones for science. So circuit symbols are similar to words, they're quick and accurate. This is a really complex circuit diagram that maybe you would use in a house building, but I've got a video for you to watch. I have filled them all in just in case you're not able to watch the video, but I would like you to watch the video so you understand what these are, but make sure you have them filled in. Then what I'm going to ask you to do on page 8 is you're going to watch that video, and again, it's just in the folder, and you're going to draw a circuit diagram for the following circuit. So I'm just going to draw that for you. Again, you're going to pause the video, hopefully go watch, pause this video, go watch the other video and come back to this. But we would have a battery, and the long end is the positive end. So again, because this end here is positive here, I have my long positive end and my short end. I'd have my wires. My wires are always drawn on right angles. And then the only other thing in this is a lamp or a light. So sometimes the schematic for a lamp or a light looks like this kind of fancy M or heart with no bottom, or like this. So either one of those are fine. Sometimes it just depends on, and I'm going to put my light right there. It's important that all the wire kind of, again, is at right angles, and that you make sure that you're not just drawing the lamp like this and putting it in. You actually have to turn it sideways and make sure it's connected to the rest of the circuit by those connecting wires. What you're going to do for the task 2 on page 8, oops, goodness, sorry. Once you've had a chance to watch the video, what you're going to do for task 2 on page 8 is you're going to look at the circuit diagrams that I've drawn for you there, and you're going to, in each of the bottom box for A all the way down to I, tell me you know, yes, the light bulb will light up, or if you're saying no, it won't light up, you're going to have to tell me what it's missing. Now, I would encourage you to refer back to the top of page 7. To light a small bulb, you need a battery, wire, something to convert the energy to light, a closed path for the energy to flow. So an example might be, yes, it will light up, or no, it won't because there's no battery. No, it won't because there's no closed path, you know, that sort of thing. If you've taken electronics, please don't worry about whether or not the voltage of the battery would support the number of lights that I had there. We're just looking, does it have those kind of four things that we need to light up? Okay, I hope that's helpful. Take care.